presentations. We have Mr. Rahul George, Country Head, Case Group, Mr. Varun Kumar, Managing Director, Dev Energy, and Dr. Prakash D. Javan, Senior Principal Scientist at CSIR CIMFR. A warm welcome to all of you gentlemen, and thank you so much for joining us. I'd request Mr. George to please start and talk to us about the innovative technologies in gasification that are being used today.
Thank you, Nisha ji, for a wonderful introduction. A very good evening to my fellow speakers and the entire audience present here. It's a pleasure to be part of probably the only platform in India for coal gasification. And since the conception of this summit, CASE has always been an active participant of this prestigious annual event. I'll just open up my slide. Okay, can you see my slide here?
Yes, Mr. George, we can see your screen. We can hear you clearly. You can go full screen and start.
Okay, the topic of my paper is coal gasification, utilizing India's huge energy reserves. As we all are aware of the fact that India possesses an enormous reserve of energy in the form of coal, which amounts to almost 300 billion tons. The challenge is how to utilize this humongous energy source within a time frame before we become a carbon neutral country. Our Honourable Prime Minister at COP26 summit in Glasgow, Scotland, has set a target to make India a carbon neutral country by 2070. An immediate commitment of 500 gigawatt power generation through non-fossil energy target for 2030. These are very optimistic and can be achieved if the right direction is taken. Under the present condition and set timelines, coal gasification is poised at an extremely positive threshold, as it can play a very vital role in substituting the use of high-cost fuels, such as furnace oil, natural gas, LDO, etc., which are being used as industrial fuels. The right coal gasification technology will not only be able to utilize India's huge coal reserves in an environmentally friendly manner, but will also assist in bridging the gap of our balance of payments by lowering our energy dependency on oil and gas imports. So in every way, coal gasification may be considered as the only way forward to utilize our coal deposits quickly, efficiently, and in an effective manner. A quick recap about who we are, what we are, and where we are. Under the leadership of our Managing Director, Mr. Roger Kumar, CASE set its footprint in the industry in the year 1993, with its head office at New Delhi and works at Bahadurgarh, Haryana. Initial setup was to manufacture industrial cooling towers and non-chemical water treatment equipment called Scaleban, which is a revolutionary product used for preventing deposition of hard water scale in heat exchangers. Both our products got a very good response from the steel industry, which got us closer to the steel industry in particular. And that is how we got associated with the steel industry in a major way. Then in 2000, in the year 2000, number of steel melting shops were in need of air pollution control equipments. So we ventured into the field by setting up bag filters, cyclone separators, scrubbers, etc. In year 2007, CASE entered coal gasification business with the hot gas technology in partnership with a Chinese company, Keyon. Fuel prices were skyrocketing at that time, and coal gas turned out to be the cheapest and most economical way of heating billets and blooms for steel rolling mills. We are proud to inform you that since 2007, CASE has successfully installed more than 300 gasifier projects for such applications. Hot gas technology had limitations of burner level automation, distance constraint for gas transportation, and pressure related issues. So in order to overcome these challenges, in the year 2013, CASE introduced pyrolysis coal clean gasifiers for special applications like automatic rolling mills, iron ore pellet plants, glass plants, etc. With development in gasification technologies, CASE in the year 2019 partnered with KEDA Group China to introduce circulating fluidized bed and entrained gasification. We will be discussing all these technology features in the upcoming slides. With all these technologies and expertise in gasification, CASE is in talks with American companies to introduce plasma gasification and give this technology to India. At this point, it is very important to have a glimpse at the coal gasification value chain. Apart from the basic use of coal gas as a thermal fuel, post-generation and reforming of gas, coal gas can be converted to liquid fuels like diesel, naphtha, gasoline, etc. Synthetic natural gas can also be produced through gasification routes. Producing fertilizers is an important and effective means of utilizing coal gas. In steel, coal gas can be used for DRI making, and with the desired heat values can also be used for power generation. So from this slide, we can study the vast use of coal gas it can have and it offers for the industrial applications. Now here I would like to run through the various coal gasification technologies which CASE is offering, point-wise understand the technology features and the applicability of them from an industrial usage point of view. Our first variant of coal gasifier is the single-stage hot gas station. This is an updraft fixed bed gasifier, and hence it is designed to gasify sized or lump coal. Optimum size of coal is 20 to 60 mm. For this gasifier, air and steam as gasifying agents are blown into the gasifier from the bottom of the gasifier. The gasifying agents pass through a bed of coal inside the gasifier shell. Oxidation and reduction reactions take place at different stages of gasification process, and coal gas is generated which flows from gasifier top. The gas is then transported through gas pipelines to utility point where it is combusted and used as a fuel for the plant's thermal demands. The most important technological feature of this gasifier is that the gas exits the gasifier at temperatures over and above 450 degrees. Thus, it is called a hot gas station. Because of this feature, all the volatiles and condensates present in the gas remain in gaseous form and become an integral part of the gas and combust at the burner point. Because of this feature, this is a zero liquid discharge technology. There is zero tar and zero phenol water which comes out of the gasification process. This is because the gas temperatures are always kept over and above the condensing temperatures of tar and condensates. Depending on the quality of coal, these gasifiers can generate gas up to 12,000 normal meter cube per hour in single cell. These gasifiers can be designed to offer a wide range of gas outputs, varying from the smallest 1,000 normal meter cube per hour to 12,000 meter cube per hour in single cells. Gas calorific values from these gasifiers can reach up to 1,800 kilocalories per normal meter cube. This is because of the volatiles present in the gas in gaseous form. To sum up, the gas thermal value for these gasifiers is a summation of gas composition plus gas volatiles plus the gas sensible heat at 450 degrees. These gasifiers are hot selling cake for the secondary steel plants for rolling mill applications, strip mills, and refractory making. Our second variant is the coal pyrolysis gasifier. As explained in my previous slide, hot gas technology had a few limitations, such as burner level automation was not possible, limitation in gas transportation, the gasifier and gas usage point had to be close to each other, distance to be maintained within 75 meters. Gas cleanliness could not be used for peculiar application where the product quality could be hampered by the impurities present in the gas. Gas pressures could not be boosted. Maximum gas pressure achievable in this case was 100 to 150 mm water column. In order to overcome the above four limitations, CASE manufactures pyrolysis coal clean gas station. Just like the hot gas station, the pyrolysis coal clean gas station is also a fixed bed gasifier, and size coal of 20 to 60 mm can be gasified through this gasifier. This is almost double in height as compared to the hot gas station. Air and steam as gasifying agents are introduced into the gasifier from the bottom. They pass through the oxidizing and reducing layers within the gasifier, and coal gas is generated. In this design, we have an added zone called the pyrolysis zone. In this zone, up to 90% of the coal volatiles are cracked into high calorific gaseous hydrocarbons, termed CNHM, which become an integral part of the coal gas. These hydrocarbons account for the higher calorific value of coal gas from these gasifiers. The gas flows from the top of the gasifier and is made to pass through a series of gas purifying equipments which extract all the gas impurities, thus making the gas clean. A gas boosting station can boost the gas as per the requirement of the burner combustion systems. Temperature of this gas at the exit of gas boosting station is kept below 45 degrees centigrade. This is done by passing the gas through an indirect water-cooled heat exchanger. At no point throughout the gasification purification process, water is made to come in direct contact with the gas. This is also a zero liquid discharge technology, like the hot gas technology. Gas condensates and phenols are treated and recycled back into the gasification process. Tar generated in the process is collected in underground concrete tanks and is used as fuel for the plant's thermal energy requirements. There is no disposal of any liquid in this technology. Just like the hot gas technology, the pyrolysis clean gas is also capable and designed to offer a wide range of gas outputs, varying from smallest 1,000 normal meter cube to 12,000 normal meter cube in a single cell. A wide range of coals can be gasified through this technology. These gasifiers have been tested to run successfully on coals having ash content up to 50%. As the gas temperatures are ambient around 45 degrees and the cleanliness of the gas is high, burner level automation becomes possible for these gasifiers. We have tested the gas from these gasifiers for extremely peculiar applications like porcelain insulators, glass plants, aluminium plants, etc. As explained earlier, these gasifiers are designed to convert coal volatiles in hydrocarbons. These hydrocarbons increase the overall calorific value of gas. We have seen that these gasifiers are capable to give gas calorific values over and above 1400 kcal per Nm3. This variant has a wide applicability. Major plants are automatic rolling mills, glass plants, pellet plants, aluminium plants, etc. A third variant is the circulating fluidized bed coal gasifier. We have partnered with Keda Group, who are the pioneers of this technology, and have successfully set up more than 100 such plants worldwide. Our main objective to incorporate the fluidized gasification technology was to overcome the challenge of availability of sized coal. For fixed bed gasification technology, lump coal is gasified. This calls for setting up a coal processing system, and the fines generated during the process of sizing were of no use to the end user. CFBC technology utilizes such coal fines and bypasses the entire process of coal preparation. A simple schematics can be set up for this technology. This technology gasifies coal fines of size less than 10 mm. Final gas temperatures after gas boosting station are kept well below 45 degrees centigrade for convenient gas transportation and usage of gas with the highest automation level. Unlike the fixed bed technology or hot gas and pyrolysis gasifiers in gasification process, through the CFBC gasifiers, there is zero generation of these hazardous substances. Thus, this technology may be termed as a zero liquid generation technology in comparison to zero liquid discharge technology. Gas calorific values with air as gasifying agents can reach up to 1300 kcal per Nm3. In case higher gas calorific values are required, then oxygen enrichment is also available with this technology. Reduction in nitrogen in final gas results in higher gas calorific values. Plants with gas CV of 1650 kcal per Nm3 are running successfully worldwide. Depending on the project commercial viability, the smallest capacity for these gasifiers is 10,000 normal meter cube, and the largest is 60,000 normal meter cube per hour in a single cell. Because of its size dynamics, these gasifiers are suitable for large plants where the plant thermal demands are relatively higher, such as aluminium calciners, iron ore pellet plants, specifically straight grade technology, integrated steel plants, and so on and so forth. A fourth variant is the entrained gasifier. One of the major limitations of CFBC gasifier is that it is capable to gasify low ash coals having ash content below 20%. This is a very big challenge for a country like India, which has abundant coal having high ash content. Thus, a need to have a technology which could successfully gasify the high ash coal was much needed. For this reason, CASE introduced the Entrained Gasification technology in partnership with CADA, a CFBC gasification partners. In this technology, the coal is pulverized to size below 100 micron and fed into the gasifier from the top along with steam and oxygen. This is a downdraft gasifier. 99.99% oxygen can be used as gasifying agents in this technology, thus reducing the nitrogen levels in the final gas. Like the CFBC technology, the entrained gasifier is also a zero liquid generation process. All the coal volatiles are combusted within the gasifier, thus the gas generated is devoid of any tar and phenolic water. These gasifiers also come in bigger capacities, varying from 10,000 normal meter cube to 80,000 normal meter cube per hour gas flows. The absence of nitrogen in the final gas helps the gas calorific values to reach up to 2,500 kilocalories per normal meter cube. Low ash coal fines can be gasified, thus making this the most efficient gasification process available today for India. This is an interesting slide which we have prepared, where we are going to show you the energy cost with respect to the various gasification technologies available in comparison to the high cost fuels that are there available in the industry. So this is this shows the cost per million kilocalories for different gasifiers. The hot gasifier cost for million kilocalories is 2050. For pyrolysis is 2140. For circulating fluidized bed gasifier, it's 1980. Entrained gasifier, it is 1680. So we can clearly see that the entrained gasifier is the most efficient economically, depending on the capex and project viability. These gasifiers can be promoted in India in a very big way. Now we've compared the energy cost of different fuels being used in the industry for thermal applications. We have taken HFO, heavy fuel oil. The cost for that for 1 million kilocalorie is roughly around 5,000 rupees per million kilocalorie. For PNG, it's 5390. For LNG, it's 6936 rupees per million kilocalorie. So we can clearly see that gasification is the ultimate source of a cheaper energy, a cheaper fuel by almost 40 to 60%. This sums up my presentation. If you have any questions, do let me know.